Alright, here we go, finishing up inverse trig functions. Now we're looking at the integrals. The integrals here look fairly complicated, and they are. So let's look at some differences between them. Again, tangent's the easiest one to recognize. It's just a constant squared plus a function squared, or an expression squared, sorry, with no radicals. Sine is the most common. It's got some kind of constant squared minus an expression squared. And then secant is the most complicated. It's got a expression squared minus a constant squared, so that's the opposite direction of the sign, but it's also got that same expression on the outside in the denominator. So it's a very special pattern in order to get it to be secant, inverse secant. Notice also the absolute value in the secant is not around the u here. It is inside the function itself. The other ones don't have absolute value. So let's look at these basic, usually start with a basic example, a little bit more complicated, so a simple u substitution or something, and then one that's a little more complicated, involving completing the square, which we'll get to in just a second. So we start off here. I always do this the long way to make sure, because there's so many little parts, to make sure everything's the same. So I look and I'm like, okay, we've got something squared minus an expression squared. So my a squared is 9, my u squared is x squared. So a is 3, u is x, and du is dx. So we can do easy substitution. This becomes du. This is a squared, this is u squared. This is definitely the inverse sine, so this is inverse sine u over a plus c. Make my substitutions. Inverse sine of u over a plus c, and we're done. Now that seems really, really simple on this really, really simple problem, but it's the same thing I'm going to do for all of the problems. So here we have a constant squared minus an expression squared. So a squared equals 3. But you may be thinking 3 is not a perfect square. That's okay. A is just the square root of 3. We don't have to worry about that. U squared is 4x squared. So u is 2x. And du is 2dx. So we do need to put in a 2 here, which puts a 1/2 out front to keep those the same. Right, because 2 times 1/2 is 1. So when I do my substitution, I get 1/2 the integral of du, square root of a squared minus u squared. So it does look like secant, or inverse sine, sorry. So we have 1/2 inverse sine of u over a plus c. So that's 1/2 inverse sine of u, which is 2x, over a, which is square root of 3, plus c. And we're done. So that doesn't seem too bad. But then we get to something like this. We have the square root of, well, that's not a constant, that's got an x with it. And this itself is not a square. So we get to do something that we haven't done in a while. It's called completing the square. We're going to look at that expression under the radical, 4x minus x squared, and we're going to try and complete the square here. Now we haven't done that in a while, and last time you did it, you had two sides of an equation to work with. We only have this expression. So first thing we do is write things in order. X squared minus x squared plus 4x. We're going to factor out anything that's in front of the x squared. So negative x squared minus 4x. Leave a blank, because now we're going to complete the square. When we complete the square, we're looking for half of this middle term, which is negative 2. And then we're going to square that middle term, and we're going to get plus 4. Now, we added 4 to the problem, so we need to subtract 4. But how many times did we add it? We added it negative 1 time, so we're going to multiply this by negative 1. So we take this number that's in front, and we multiply this by that number as well. Now I wrote this number, this immediate number, intermediate number, because when we factor this, it becomes super easy. We have the negative factor on the outside. This becomes x minus 2 squared, and this becomes plus 4. So as you can see, if we rewrite this just a little bit, we have a constant squared minus an expression squared. So we're going to take this, we're going to stick that in here, and it's going to work out for us. We have the integral of 1 over the square root of 4 minus x minus 2, squared dx. So then we go into our routine. A squared equals 4, a equals 2, a squared equals x minus 2 squared, u is x minus 2, du is dx. Substitute, we get 1 over square root of a squared minus u squared du. So it's definitely inverse sine. Inverse sine of u over a. Doing it this way also helps me memorize the formula because I'm writing it every time on the homework. And we get the inverse sine of u, which is x minus 2, over a, 2, plus c. If you want to simplify that to 1/2 x minus 1, you can. It really doesn't matter. Both, it'll work. All right, so let's look at more examples. We're going to move to tangent now. Tangent's just as easy. Again, we've got a constant squared here, which is 10, a function squared here, which is x. So a is square root of 10, x is, or u is, u is x. That sounds funny to say u is. And du is dx. Doing our substitution, we get a squared plus u squared du. That is tangent. So we get 1 over a inverse tangent of u over a plus c. So 1 over the root 10 inverse tangent of x over root 10 plus c. Doing the same thing, just a little more complication. A squared equals 7, a equals square root of 7. U squared equals 3x squared, so u is root 3x. Du is root 3 dx. So let's see here. I need a root 3 to go with my dx to make du, so I need to divide by root 3 on the outside to keep it balanced. So I have 1 over root 3, integral of 1 over a squared, u squared, and du. This is inverse tangent. Oops, forgot my 1 over a. So this is 1 over root 3 times 1 over root 7, inverse tangent of root 3x over root 7. Simplifying this just a little bit, we have 1 over root 21, inverse tangent of root 3 over 7 times x. You can combine that, or you can leave them two separate. Both is fine. I'm left off my plus c, and we're good. Okay. So we look here, no radicals. So we're thinking inverse tangent, but we have, that's something squared, that's a constant squared, but the 4x is throwing us off. You guessed it, we're going to have to do complete the square. So completing the square, we take our function 4x squared plus 4x plus 2, or our expression rather. We're going to group everything that has x in it and factor that out. Anything in front of x squared out. We have 4 times x squared plus x plus something is plus 2. We half this, so half of this is half. We square it, so this is 1/2, this is square. We get 1/4. So we added 1/4, we're going to subtract 1/4. How many times? 4. So we go 4 times, this factor's easy, it's x plus 1/2 squared. I like to use this little space to do the quick calculation here. That's just a 1. So 2 minus 1 is 1. So we're going to stick that back in here. 1 over 4x plus 1/2 squared plus 1 dx. So here is our expression that's squared. 4 is squared, this is squared, that works. So this is a constant, and this is our variable. So a squared is 1. Notice it's over here this time. U squared is 4x plus 1/2 squared. So a is 1, u is 2 times x plus 1/2, which simplifies to 2x plus 1. du is 2 dx. So we do need a 2 multiplied on the inside to go with our dx. We need a 1/2 on the outside to balance that 2. So I have a 1/2 times the integral of 1 over u squared plus a squared du. Well, that works. U squared plus a squared is the same as a squared plus u squared. Order doesn't matter. And we're left with 1/2 inverse tangent of u over a. Oops, I should have 1 over a on the outside too. Keep forgetting that one. So 1/2 times 1 over 1 in this case. Inverse tangent of 2x plus 1 over 1 plus c. Simplify that just a little bit to get rid of the silly things like multiplying by 1. And we end up with this. So, not too bad until you get to the part where you have to complete the square. You're going to complete the square anytime that you don't have an expression that can be written as something squared. Even if part of it is squared, it means the whole expression needs to be squared. Okay, so let's see what inverse secant looks like. So we look at this right here. We have something on the outside, and function squared here, or expression squared here, and a constant squared here. So a squared is going to be 5. A is root 5. No big deal. U squared is 4x squared, so u is 2x. du is 2 dx. Well, that works in that we have a squared here, we've got u squared here. This is not u. To make that u, I need to make this a 2. Well, that means I need a 2 on the top. Okay, well, let's put 2 on the top, see what that does. So that's u. Oh, look, 2 dx. Now this is du. And you'll find that happens a lot of the time when you have secant. When you fix this u down here, the top fixes itself, or vice versa. You fix the top and the u gets fixed as well. So when we do our substitutions, we get 1 over, this becomes u. We have the square root of u squared minus a squared, and that becomes our du. So this is inverse secant. So you have 1 over a inverse secant of the absolute value of u over a plus c. So this is 1 over root 5 inverse secant of 2x over root 5 plus c.